Welcome to Unit 5, Lesson 5, Special Linear Systems. So this is going to be a little bit different than what we've been doing with our linear systems. We're going to talk about the different types that we have. So first thing I want you to do is I want you to solve this linear system using any method that you know. You can graph it, you can use substitution, or you can use elimination. And after you do that, you should see something interesting happen. So go ahead and discuss what you see with your group. So go ahead and pause the video and do that now. Okay. So I'm going to pause the video here real fast and we're going to jump and I'm going to solve this. And at some point you should have ran into a situation like this, where you cannot go any further. You cannot solve it any further. You get 0 equals 4 if you do elimination. If you do substitution, you get something else. If you graph, you see something else. So, what does it mean if we get stopped here? So I want you to go ahead, pause the video, and discuss that with your group now. Alright. What it means is there is no solution. Sometimes our linear systems will have no solution. This is a special case when this happens. So, when that happens, I want you to look at the first example we did by graphing it in GeoGebra. So I want you to graph these two lines in GeoGebra. And just to make it easier, whenever you do that, I want you to just type these lines straight in. Just type in 2x plus y equals 5 and 2x plus y equals 1. Graph it in GeoGebra. So go ahead, pause the video, do this, and discuss what you see with your group. Okay. What you should have saw in your group is that these two lines are parallel. They're never going to touch. So if you think about it, it kind of makes sense, since whenever we graphed before, they intersected at one point. Well, here, they don't ever intersect. Therefore, they will never have a solution. So that's why there's no solution. Okay, so I want you to go ahead and solve this and see if there's no solution or not. You can solve it by graphing, substitution, or by elimination. So go ahead and do that now. And I worked this one out through substitution, but either way you work it out, you should see that you do get no solution. Okay, here's another example I want you to try with your group. So go ahead, pause the video, and solve this using any method that you choose. So go ahead, pause the video now. And after you solve, you should see that you get y equals 0 and x equals 2, which means that this isn't no solution, it has a solution. So, this is a one solution problem. All the linear systems we have worked with before today, meaning the two special cases we're going to learn, have had one solution. So again, I want you to graph that first example we did on the graph. I want you to look at the graph, see what happens, and compare that to our no solution. So go ahead, pause the video, and graph that now. In comparison to our first example, our first special case, these two lines are going to intersect. So because they intersect, they have a solution. And because they only intersect at one point, they have one solution. Okay. Next, I want you to try this example and tell me what happens. So go ahead, pause the video, solve this with your group now. So here's what happens when you solve this using elimination. And you see that we get 0 equals 0. And if you solved it using substitution or you graphed it, you'd see something similar. So what does this mean? So I want you to go ahead and pause the video again and discuss in your group what you think this means. Okay, what this means is that this linear system has infinitely many solutions. So some cases our linear systems will have an infinite amount of solutions. It doesn't matter what two numbers you pick for x and y, they will always work. That's what that means. So to look at this, let's go ahead and I want you to graph that first example, 2x plus 8y equals 6, negative x minus 4y equals negative 3. So go ahead, graph it, and see what happens now. Alright, whenever you graph this, what I hope you would have saw was that there is no difference between the two lines. That this line right here is the exact same line as this. That's why there's an infinite amount of solutions, because they're exactly the same. Okay, so I want you to go ahead and see if this has infinitely many solutions, one solution, or no solution. So go ahead, pause the video, and work through this now. And after you work through, you will see that it does have infinitely many solutions.